arrangement of the preparation of carbon dioxide. Arrangement of preparation. Yes, welcome to the channel, and we are going to study now about the preparation of carbon dioxide in the laboratory. Preparation of carbon dioxide in the laboratory. So this figure is drawn here is preparation of carbon dioxide, arrangement of the preparation of carbon dioxide in the laboratory. What is this figure showing? Arrangement of preparation. Preparation of CO2 in the laboratory. How to prepare carbon CO2? Carbon dioxide can be prepared in the laboratory like this. Take a round bottomed flask. In the round bottomed flask, have some marble pieces, that is CaCO3. This is CaCO3 taken here. Marble pieces enough. Marble pieces is calcium carbonate, CaCO3. Then it is closed with a two-holed cork. The flask is closed with a two-holed cork. Through one hole, a thistle funnel is introduced. Through one hole, a thistle funnel is introduced. Through the other hole, a bent delivery tube. Through the other hole, a bent delivery tube is introduced. Here is the bend. And the bent delivery tube is introduced a gas jar. The gas jar is for collecting CO2. The bent delivery tube is introduced in the bottom of the jar. This is gas jar. The bent delivery tube is introduced in the bottom of the gas jar. This is clamped on a stand. The apparatus. This flask, round bottom flask, is clamped on a stand to the connection given. And to the neck region, it is connection is given and clamped. And here there is the stand on that for the gas fluid system. Then acid is for dilute hydrochloric acid is enough. Dilute hydrochloric acid is enough. So this is the preparation of carbon dioxide in the laboratory. Which are the reactants used? Calcium carbonate, that is marble, is used. Calcium carbonate and hydrochloric acid are the reactants used. Complete the equation of the reaction. What is the reaction? CaCO3 plus 2 HCl gives CaCl2 plus H2O. Calcium carbonate plus hydrochloric acid gives calcium chloride plus water plus carbon dioxide. So the equation is going to be written here. Let me write the equation here on the board. Equation for the production of carbon dioxide in the laboratory. Marble is taken. What is marble? Marble is taken. What is marble? Marble is CaCO3. Calcium carbonate. CaCO3 plus 2HCl. CaCO3 plus 2HCl. Hydrochloric acid. Chemically, what is it? Hydrogen chloride. Gives Ca, calcium. Ca, this Ca, and this 2Cl here. 2 atoms of chlorine. Cl2, CaCl2 plus here 2H as H2 we can write here. 2H as H2 and here 3 atoms of oxygen. 1 atom of oxygen taken to water plus then what? Out of the oxygen atoms, out of the 3 oxygen atoms here, 2 oxygen atoms are balanced and C has not taken here, carbon. That is C here, C, then 2 oxygen atoms, O2, CO2, CO2. So, this is the equation. CaCO3 calcium carbonate plus 2 HCl gives CaCl2 plus H2O plus CO2. What are the reactants? Marble and hydrochloric acid. CaCO3 calcium carbonate plus 2HCl gives CaCl2 calcium chloride plus H2O plus CO2. Thus, in the laboratory, carbon dioxide is prepared. And left side there. Graphenes, GRAPHNES. Graphenes are two-dimensional sheets of hexagonal rings formed by carbon. So graphenes are two-dimensional. We are going to study now about the arrangement of atoms of graphene. Here you can see two-dimensional arrangement. That two-dimensional arrangement is in a hexagonal fashion. 3, 4, 5, 6. Like that, it is arranged. 1, 2, 3, 4, 5, 6. It goes on like this. In this fashion, the atoms are arranged 1, 2, 3, 4, 5, 6. Got like this. In this way, everywhere like this. In this fashion, all are hexagonal. GRAPHENS. Graphenes are two-dimensional sheets. What are these graphenes? GRAPHENS. Graphenes are two-dimensional sheet. What is meant by two-dimensional? One-dimensional, two-dimensional, three-dimensional. One-dimensional means like this. Two-dimensional means there is a breadth also. This is one-dimensional. This is two-dimensional. And what is three-dimensional? When it is three-dimensional, we say there is a height also. This is three-dimensional. Here length only. Here length and breadth are there. Length, breadth and height are there. Is three-dimensional. Graphene just plate is one layer. Breadth and length are there. No height. So this is two-dimensional. Graphenes are two-dimensional sheets of hexagonal rings. These rings are made up of rings, hexagonal, six-sided, formed by carbon. Graphenes resemble a single layer of graphite. So it is like a graphene. It is like a single layer of graphite. It can be said that graphenes are the basic units of the allotropes of carbon. Graphenes. These graphenes are the basic unit. Graphenes are the basic units of the allotropes of carbon. Are the basic units of the allotropes of carbon. What are the basic units of the allotropes of carbon? Graphenes. It can be said that graphenes are the basic units of the allotropes of carbon. So all the allotropes of carbon are made by these graphenes. Like graphite and fullerenes. Graphite is made with these graphenes like this. Fullerenes also made by graphenes like this. What are graphenes? Graphenes are the basic units with which the allotropic forms are made. The allotropic forms like graphite, fullerenes, etc. are made by the basic units like this, made by graphenes. Let us list some of the characteristics of graphene. So we are studying about the basic unit with which graphite, fullerenes, etc. are made. Let us study the basic characteristics of this. 200 times stronger than steel. So this graphene structure is very strong. So it is 200 times stronger than steel. conductor of heat and electricity. Graphenes conduct heat and electricity. What is the reason should be for conducting heat and electricity? There could be free electrons in this reason. Both conductor. Heat and electricity both are conducted. Graphene has already emerged as a material that has revolutionized the field of nanotechnology. So the material graphene is used here for nanotechnology. Graphene has already emerged as a material that has revolutionized the field of nanotechnology. That is, it is considerably used in the field of nanotechnology. What is the use of graphene? Graphene is considerably used for the purpose of nanotechnology. Then what are the reactants used? That's all that. Pick the correct ones given below. Colored, colorless. But about carbon dioxide is now we have something more studying about carbon dioxide. Let us study the properties of carbon dioxide. Physical properties and chemical properties are them. And physical properties it is heavier than air, 2.5 times as heavy as air. Colorless gas. Colorless, odorless, no smell. Colorless, odorless gas. It is 2.5 times as heavy as air. That's why it displays the air upwards and gets collected at the bottom of the jar. Pick out the correct ones given here. We are telling here about the CO2 gas. Given two things. Colored, colorless. It is colorless. CO2 is colorless. Supporter of combustion, not a supporter of combustion. CO2 is not a supporter of combustion. It only extinguishes fire. So not a supporter, of burning, not a supporter of combustion. CO2 is not a supporter of combustion. Has odor, odorless. Odor means smell. No smell, odorless. ODOUR-LESS, odorless. ODOUR, odor, smell. Odor. ODOUR-LESS, odorless. CO2 is odorless, colorless, odorless gas, not a supporter of combustion. Denser than air, lighter than air. This is denser than air. How many times? 2.5 times. 2.5 times heavier than air. So it sinks to the bottom. Whether the aqueous solution of carbon dioxide is acidic or alkaline? Aqueous solution is alkaline. It is acidic carbon dioxide. Aqueous solution of carbon dioxide is acidic. How is it? Carbonic acid is formed. What acid? Acidic. Carbonic acid. What is the formula for carbonic acid? H2CO3. H2O plus CO2 gives H2CO3. Whether the aqueous solution of carbon dioxide is acidic or alkaline, it is acidic. Write the chemical formulae and uses of some carbonates. We have to write the chemical formulae and uses of some carbonates. Let us write the chemical formula. Marble, calcium carbonate, CaCO3. It is used for putting flour. It is also used for marble pieces can be used for producing carbon dioxide. You never remember laboratory preparation. Calcium carbonate. Then what other carbonates? Sodium carbonate. Na2CO3. Sodium carbonate. Na2CO3. Sodium carbonate. Sodium carbonate is used. Sodium carbonate is used for making glass. Na2CO3. Sodium carbonate is used for making glass in the glass factory. Sand is put silicon and sodium silicate will come. Na2SiO3, sodium silicate. Silicon added, then Na2CO3 plus silicon dioxide is Na2SiO3 sodium silicate. This is glass, and glass is a mixture of sodium silicate and calcium silicate. Glass is a mixture of sodium silicate and calcium silicate. So carbonates, calcium carbonate, sodium carbonate, then what? Potassium carbonate, K2CO3, K potassium, K2CO3, potassium carbonate. It can be used as manure to get potassium salts. It can be put for plants. Potassium carbonate. Then other carbonates are magnesium carbonate, MgCO3. So these are the tasks here. Some carbonates and their uses. CaCO3 is marble, used for flooring, and species used for the preparation of carbon dioxide. Sodium carbonate is washing soda, which can be used for washing clothes. Earlier days, this was used for washing clothes, but nowadays that is not used as soap and detergents are there. And the sodium carbonate can be used for removing the hardness of water. Hard water means water that does not give lather with the soap, then it is hardened. To remove the hardness of water, sodium carbonate can be used. Sodium carbonate is used for removing the hardness of water. How can we identify this then? Write the chemical formula and uses of some carbonates. Let us examine how carbonates can be identified. Carbonates identifying. How can carbonates be identified? Means the test for carbonate is asked here. Say material is given. We don't know whether it is carbonate. So take that in a test tube. The given substance or the given salt is carbonate or not. We have to understand. What is to do for this? Add dilute HCl and heat. So this is the salt. Test for carbonate. Let it be any carbonate. We don't know what carbonate. Let us give an example. Suppose it is CaCO3, calcium carbonate. Suppose calcium or sodium, potassium, anything can be. And if it is carbonate, when heated, adding dilute hydrochloric acid. Heated adding dilute HCl gives what? Ca2HCl. CaCl2 plus 2H here. H2. And from CO3, 3 oxygen are there. 1 oxygen will be taken with H2O plus C here, and 2 oxygen atoms are there, CO2. So this gives as goes out as gas. This goes out as gas. We will be able to see reaction taking place here. When HCl is passed here, bubbles will be coming out. Foam will be formed. Foaming and frothing will be there. Foaming and frothing could be seen. It will come out with foam and froth. So, and that is a brisk effervescence. Coming like this is called effervescence. B-R-I-S-K. Brisk means strong. It will come out. Foaming and frothing will come out. That we say effervescence. Brisk effervescence. EFFERVESCENCE. Brisk effervescence with the evolution of a gas. It is a colorless gas, and this brisk effervescence with a colorless gas. So as the gas is a colorless gas, we won't be able to see it, but we have a test for that. We can test it. What is that test? We have to show a glass rod dipped in lime water. Lime water, what is lime water? Lime water is calcium hydroxide. And if it is carbon dioxide, what happens is that CaCO3 will be formed. Plus CaCO3 twice. CaCO3 plus H2O. Calcium carbonate and water are formed. So what will be seen here? The lime water will be termed milky. A drop of lime water. Glass rod dipped in lime water is introduced at the mouth of the test tube. Then lime water is turned milky, means water, no color. A drop of water, no color. And a drop of milk how will be slight white color. White color will be. So it is turned milky. Glass rod dipped in lime water is turned milky. This is the test for carbon dioxide. So gas evolves and a glass rod dipped in lime water is introduced at the mouth of the test tube when it turns milky. So that's the test for carbon dioxide. So add some dilute HCl to the given salt. Let us examine how carbonate can be detected. What is the confirmatory test for carbonate? Detection of carbonate. Add dilute hydrochloric acid and heat it. Add some dilute hydrochloric acid to the given salt. If a colorless gas turns lime water milky, heating is not necessary. Even without heating, it will reaction will take place. So not necessary to heat it. No need of heating. Take a test tube and take some marble pieces in it. The given salt is put in it and add dilute hydrochloric acid. Then brisk effervescence will come. It is if a colorless gas that turns lime water milky is formed, that salt will be carbonate. You know that the gas formed is carbon dioxide. Brisk effervescence in that the gas formed is carbon dioxide. The variety of carbon compounds is used. A variety of carbon compounds is essential for the existence of life on Earth. Variety of carbon compounds, not carbon dioxide alone. Carbon dioxide is a carbon compound, but it is an inorganic compound. A variety of carbon compounds. What are the carbon compounds? H2CO3 is required. That is carbonic acid in body. This is inorganic. And many organic compounds like C6, H12, O6. This is glucose. Glucose, fructose, amino acids, fatty acids, like that. Many organic compounds are required for the life, existence of life on Earth. How does the life exist on Earth? Many organic compounds are there. With that, our protoplasm is made. There are many organic compounds and some inorganic compounds with which our body is made of and its life. Our body contains water. Water is inorganic. There is carbon dioxide in the body. It is inorganic. There is carbonic acid in the body. It is inorganic. And inorganic and organic substances are there in the body. Most of the substances are organic substances. There are thousands of organic substances in our body. Organic substances means substances which contain hydrogen and carbon. The variety of carbon compounds is essential for the existence of life on Earth. Shows the way in which carbon is exchanged over the carbon dioxide is exchanged over there. It is not like that because in the atmosphere there is carbon dioxide, and with that no life formed. Carbon dioxide is brought to the earth, and carbon compounds are made. Organic compounds are made, and thus the body of living organisms are made. Carbon dioxide which is in the atmosphere is not in the living beings, but that is brought down to earth during photosynthesis. And carbon compounds are made. So there is the body of the organisms which is made up of mostly carbon compounds. Which carbon dioxide is exchanged over the earth. This is known as carbon cycle. So what is carbon cycle? There is the cyclic movement of the cyclic transfer of carbon from the atmosphere to the earth and from the earth to the atmosphere is called carbon cycle. That is carbon dioxide in the atmosphere. During photosynthesis, it is brought by plants to the earth, and carbon compounds are made. Carbon compounds. Carbon compounds are made in the body of the organisms. When they die by burning or rotting, burning or decay, it will go back. Carbon dioxide is brought to the earth, and from the earth, when it goes to the atmosphere, this is called carbon cycle. Carbon dioxide is brought to earth and carbon compounds are made. So there is a cyclic movement of carbon compounds to earth and back to earth. Carbon dioxide is brought to earth and carbon compounds are made and it goes back. So let us please subscribe.